Hey students, how you doing today? We are going to get into our most important two lessons of the school year, in my opinion. And the simple truth is because if you can do this lesson here tonight and make sense of it, and make sense of the practice that we're doing tomorrow, the next chapter, when we're doing the exact same thing but with a different parent function, you'll already know how to do it. And the chapter after that, when I give you a new parent function, you'll be able to graph that one without a problem at all. And this is all under the same lesson, and we are graphing transformations. Um, let's go ahead and get into this. This lesson is for team non-graph paper. So suppose you had this f of x equation, and it's just a graph, and they give you these three coordinates. They give you the coordinate 0, 3, they give you the coordinate 2, 5, and they give you the coordinate negative 3, 7. And they'd like us to graph g of x, which is equal to negative f of x plus 3 over 5 minus 4. Now, I guess before I get into that graph, I want to show you, I typed up and I formalized this transformation sheet that I've been talking about. And I also broke it up into horizontal and vertical transformations. As we talked about in previous lessons, anything that's seen outside of the function is going to give you a vertical transformation. This positive negative out front, if it's negative, that's going to give you an x-axis reflection. If you are multiplying the function by a number b, that would be a vertical dilation by a factor of that b. The k, the plus k on the end, that is a vertical translation of k units. Whereas inside, anything going on inside of the function is going to be a horizontal transformation and affect the x coordinates. If you have this negative on the inside, a negative x, that is a y-axis reflection. This a represents a horizontal dilation by a factor of a. And this h represents a horizontal translation of h units. Notes the inside, outside, backwards or not backwards bit of this. Outside, the plus k, so you're going k units up, or you're multiplying by b, so you're multiplying the coordinate by b. Whereas in here, it's always opposite. That instead of being an addition, it's a subtraction that's giving you that horizontal translation. Or instead of being multiplied, that gave us the vertical on the inside, it's a dividing on the inside that will do that. But then, if you have these transformations, what does that physically do to the xy coordinate? Well, it would do this. On the inside, that affects the x. If there's a reflection, you'd go with the negative x. A horizontal dilation by a factor of a, you'd be multiplying the x coordinate by a, and then you'd add the horizontal translation to it. This negative here for the y coordinate, that's for your x-axis reflection. The vertical dilation is this b that you're multiplying the y coordinate by, and then the k is what you're adding or subtracting depending on if your graph is going up or down. So if you're struggling with these, I would say print this up and start asking questions about this particular worksheet. This is a guide to how to solve all these other problems, and this isn't just this chapter, it's chapters in the future. So this negative out front, that's the same as this negative out front here, so that is our x-axis reflection. So I know I have an x-axis reflection. This divided by 5, it's on the inside, so that's like this a here. So that is a horizontal dilation by a factor of a, and it's 5. So a horizontal dilation by a factor of 5. And then those are the multipliers, so those are the reflections and the dilations. And then because of this x plus 3, I know that the graph would be going left 3, and because of this minus 4, the graph is going to be going down 4. Well, what does that physically do to the coordinates? Well, x, y, if I apply, well, let's see, what's going to affect the x-coordinate? The things that are going to affect the x-coordinate are this horizontal dilation and the left 3. Those are going to be on the x-coordinate. Horizontal dilation means that you multiply the x-coordinate by this 5, and then after you've applied the dilation, you would then travel left 3, and if you're going to be traveling 3 coordinates to the left, that means that you would subtract 3 from the x-coordinate. The y-coordinate, there's an x-axis reflection, so that would be a negative y, and then it's going down 4, so after you've done the reflection, it then goes down 4, so you'd subtract 4. Okay, for coordinate analysis, inside you do the exact opposite. So instead of dividing by 5, we multiplied by 5. Instead of adding 3, we subtracted 3. Outside, you do exactly what they tell you to. You first multiply the entire function by a negative, so negative y, and then after it you're subtracting 4, so minus 4. So I need to do these transformations onto these 3 points up here. So I then write out my list, negative 3, 7, 0, 3, and 2, 5. I like to go coordinate by coordinate so I don't get so confused, because this can get complicated. So 5 times negative 3 is negative 15. Negative 15 minus 8 is negative 18. 5 times 0 is 0. 0 minus 3 is negative 3. 2 times 5 is 10. 10 minus 3, 7. Y-coordinates. Negative 7 minus 4 is negative 11. Negative 3 minus 4 is negative 7. And negative 5 minus 4 is negative 9. And then you just go ahead and graph this. You may want to make your little x and y just to make sure you're putting these coordinates in the right spot. So negative 18, negative 11, that would be way down here. So negative 18 comma negative 11, that was my first point. Then my second point was negative 3, negative 7. And my third point was positive 7, negative 9. So your graph might not look perfectly the same, but at the end of the day, because you're team non-graph paper, all I'm going to do as your grader is look at these 3 coordinates and make sure that those 3 coordinates are in the exact appropriate spot. Okay, that was our first example. I'd like to do one more example with you, but I want you to try this one out on your own, because if you get this problem and you understood what we did with it, then number 2 should actually be quite similar. So using the exact same f of x, try to graph this one. We have 3 times f of negative x plus 6, close parentheses, plus 5. So do me a favor, everybody. Pause this video, try this problem out on your own, and then once you've tried the problem out or you got stuck on it, play the video again and get it filled in correctly. Alright, so I'm going to start solving the problem in one bite of my lunch. Sorry about that, you shouldn't have to watch somebody eat. Okay, let's see. I'm going to do an inside-outside, kind of keep them separate. On the inside, I have this negative on the inside that shows a, if it's on the inside, it's affecting the x-coordinate, so that's a y-axis reflection. And on the and then still on the inside of the function, I have this x plus 6, that shows that it would be going left 6. So as far as the xy coordinate goes, a y-axis reflection means that it would be negative x, and then after you apply the reflection, you then apply the left 6, and if you're traveling left 6, you're subtracting, so minus 6. Outside the function, I notice that we are multiplying the function by 3, so that's a vertical dilation by a factor of 3. And then this plus 5 on the outside shows that it's going up 5. So a vertical dilation by a factor of 3 means that you're going to multiply the y-coordinate by 3, and then if you're going up 5, it would be a plus 5. Okay, now you do that exact same thing with all 3 coordinates. So I have negative 3, 7, 0, 3, 2, 5. Negative 3 is positive 3. 3 minus 6 is negative 3. Interesting. Negative 0 minus 6 is negative 6. And negative 2 minus 6 is negative 8. And then the y-coordinates. 3 times 7 is 21. 21 plus 5 is 26. Enjoy that one, team graph paper. 3 times 3 is 9, and 9 plus 5 is 14, and 5 times 3 is 15, 15 plus 5 is 20. So I have those 3 coordinates, and then make your graph estimate. So let's see, it started with negative 3, 26, that would be way up here. Then negative 6, 14. Maybe be approximately there. And then finally negative 8, 20, so y would be slightly in between. Connect the dots, la 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 la. And my friends, we have a nice, beautiful transformed graph. So those are graphs that involved 4 transformations. Tomorrow you're going to get a worksheet that just covers you're going to have some single transformations, doubles, triples, quadruples, 5 transformations, and ultimately 6 transformations. But I'm going to tell you right now that if you can do a graph involving 4 transformations and be comfortable with a 4 transformation graph, we're not going to quiz you or test you on 5 or 6 transformations. That's pretty... Yeah, you don't usually see equations like that, but I could see giving you one that has 4 transformations. So try to get comfortable with 4 transformation graphs, and then we're going to spend the next day doing these beautiful graphs, and it's going to be good times. So enjoy your Wednesday evening, everybody, and I'll see you tomorrow for an awesome day of worksheet solving. Bye bye.